Welcome viewers, in this video we will see the number based conversion from binary to octal. So this system coming under grouping techniques. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic binary to octal. So why we are calling as a grouping technique? We need to group the given digits. 3 digits or 4 digits. In case of octal, the binary number is grouped into 3 digits. In case of hexadecimal, the given binary number is grouped into 4 digits. That's why it is called a grouping techniques. The conversion videos are available. Consecutive videos are available. In this video, we'll see binary to octal. There are two examples available. First, we'll see the example 1. So, this is a given binary number. We need to convert into octal number. Binary to octal. The binary number is 1111110. This is the given binary number. We need to convert into octal. It is 376. We got the answer as 376. We'll see how we got this answer. So as a grouping technique, while converting into octal, this given binary number should be grouped into 3 digits starting from LSB. Starting from LSB, we need to group into 3 digits. So this 011 is the first 3 digits. Then 111, another 3 digits. Here only 2 ones are available. So we need to add 10 in the as a MSB. So it will not affect. The original value will not affect. Right. So there are 8 digits available. That is grouped into 3 digits, another 3 digits, another 2 digits, and 10 is added. Right. So while converting binary to octal, the given number binary number should be grouped into 3 digits. That is the first step. If one digit is not available, mean we need to add 0. Right. So here 011 is one first 3 digit. 111 is the second 3 digit. 11. So we added 0. So that is the third 3 digits. Now we need to convert this binary, these 3 digit alone. These 3 digit alone into into octal. This separately to the octal system, right? These 3 digits separately, these 3 digits separately, and these 3 digits separately. What is this digit? 110. How will we need to multiply with the weightage? What is the weightage? 8421. What is 8421? This 2 to the 1 means nothing but 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. So that is given written shortly. 2 to the power 0 means 1. 2 to the power 1 means 2. 2 to the power 2. 2 square means 4. 2 cube means 8. So we need to multiply with 8421. Right. So that is coming from 2 to the power 0, 1, 2, 3. But here octal is there. So only we need 4 to 1. In hexadecimal we can use this weightage 8421. For octal we need to use the 4 to 1 because only 3 digits are available. So this is 4 to 1 is nothing but we got from the weightage 2 to the power 0, 1, 2, 3. So this binary number should be multiplied with the corresponding digits multiplied with 4 to 1. Similarly this 4 to 1, this 4 to 1. So here 0 is available. So 0, so this first digit become 0. Here 1 is available. So we have 1 into 2, 2. 1 into 4, 4. So 4 plus 2, 6. This 1 is 0. So we need to no need to consider this 1. So 4 plus 1, 6. Here all ones are available. So 4 plus 2, 6. 6 plus 1, 7. Right. So according to the weightage, we need to add this value. Here all ones are available. So all digits are added together. 4 plus 2 plus 1, 7. Here third digit is 0. So first 2 digits only added. 4 plus 2, 6. So the normal is nothing but 0 plus 1, 0 into 1 plus 1 into 2 plus 1 into 4. So that we got this value. So shortly we are writing this. Similarly here first digit is 0. Only second and third digit is available. That is 2 and 1. So 2 plus 1, 3. Right. So first the binary number is grouped into 3 digits. Then this weightage is written 4 to 1, 4 to 1 based on this weightage. Hexadecimal we need to use 8421. Octal we need to use only 4 to 1. Now based on this value 0, 1, 1, 0 means first two digits are 1, third digit is 0. So first add first two digits, 4 plus 2, 6. Here all three digits are available. So 4 plus 6, 4 plus 2 plus 1, 7. The first digit is 0, second and third. So 2 plus 1, 3. So now this write this. This is nothing but a octal equivalent. 376 base 8. So the given binary number, the equivalent octal number is 376. Right? How we are doing? The binary number is grouped into 3 digits. This shortage means we need to add 0. Then this weightage is written based on the decimal value 1 or 0. These weightages are added and written separately. This is done separately, this one done separately, right? Then combine together 376 base 8. Right? This is the octal equivalent of the given binary number. Now we'll go to the second example, example 2. 111 111 right, 111 to base 2. This binary should be converted into octal. So while converting, what we got? 1677. We will see how we got this value 1677, right? So we already informed we need to write this three digits. The given binary number should be written in three digits, right? So here first 111 is available, another 111 is available, then 011. Finally only 1 is available, but we need 3 digits, so add 2 zeros. It will not affect the original value, right? So given binary number should be grouped into 3 digits starting from LSB. This is the LSB, least significant bit. This is most significant bit, not from this side, not from starting from LSB, right? 111 is written, another 111, 011, remaining 1 is available. For that, make it into 3 digits, 2 zeros are added, right? Now we have 4 different 3 digits are available, 4 groupings are available. Now we need to apply this weightage 4 to 1. We already discussed what is 4 to 1, right? 4 to 1, 4 to 1. This 4 to 1, all ones are available. So 4 plus 2 plus 1, 7. The value is 7. Here also all 3s are available. So 4 plus 2 plus 1, 7. What is the actual meaning? 1 into 1 plus 1 into 2 plus 1 into 4. So 4 plus 2 plus 1, 7. That is the normal meaning. Shortly we are writing this. Here 1 is available, last digit is 0. So first add first 2 digits alone. 4 plus 2, 6. Right? Here first 2 digits are 0, only the last one is 1. So only 1 will be there. 4 and 6 we cannot add it. It becomes 0 because of 0, 0. So 1 into 1, 1. So combine these digits 1, 6, 7, 7. So this is nothing but the octal equivalent of a given binary number, right? So how we are doing? First step, write the given binary number into 3 digits starting from LSB. Convert this 3 digit into the decimal number separately. This one separately. Each and the 3 digits are converted into decimal separately by using this weightage 4 to 1. Then combine all this value. That is nothing but your the octal equivalent 1677. Right? This binary number, the octal equivalent is 1677. So in this video we discuss binary to octal number based conversion with 2 examples. Other conversion system also available in the separate videos. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening. Welcome viewers, in this video we will see the binary to hexadecimal number based conversion from binary number to hexadecimal number. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we'll go to the topic binary to hexadecimal. Binary means base 2, hexadecimal base 16. So base 2 to base 16 we need to convert. So this is coming under grouping techniques. We need to group the numbers. For example, octal mean we need to group into 3 digits. The given binary number should be grouped into 3 digits. In case of hexadecimal, it should be grouped into 4 digits. Right? So that it is coming under the grouping techniques. Right? So first we will consider this binary number In order to convert into hexadecimal, we need to group into 4 digits starting from LSB. Starting from LSB, the given binary number should be grouped into 4 digits. So here what is available? 0, 1, 1, 0. Starting from LSB, it is 0, 1, 1, 0. Another 1, 1, 1, 1. All ones are available. Another 1, 1, 0, 1. Right? Here totally 12 digits are available. So it is grouped into 3 4 digits. This is one 4 digit, another 4 digit, another 4 digit. Right? So it is written. If any digit is shortage, we need to add 0. But here exactly 12 digits are available. Right? So the first step is given binary number should be grouped into 4 digits separately starting from LSB. Now convert this 4 digit into decimal separately. This 4 digit into decimal separately you have to convert. These 4 digits separately to decimal, these 4 digits separately to decimal, these 4 digits separately to decimal. How to convert this decimal? By using the multiplication, successive multiplication. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. It's go like that. Right? What is 2 to the power 2 means? 1. 2 to the power 1 means 2. 2 to the power 2 means 4. 2 to the power 3 means 8. So 8421. The weightage is 8421. That is coming from this 2 to the power 0, 1, 2, 3. So we can multiply with this 8421. Simply we can multiply. Right? This is the normal method. 0 into 2 to the power 0. 1 into 2 to the power 1. But for simplification we can write 8421. So here we need to convert separately. Here we need to convert separately. Here separately. So 8421 is written in each and every 4 digits. Here first digit is 0, only second and third digit is available. So add only these 4 plus 2, 6. This 8 and 1 is 0. 8 into 0, 1 into 0. Only this 1 into 4 plus 1 into 2. So 4 plus 2, 6. Here all ones are available. So 8 plus 4, 12. 12 plus 2, 14. 14 plus 1, 15. Right? All ones are available. Here 1101. First 2 digits available, third digit is 0, fourth digit available. So 8 plus 4, 12. This 2 is 0. So 12 plus 1, 13. So 8 plus 4 plus 1, 13. So this 2 is not added. Now got 13, 15, 6. Right? So in this we need to convert into decimal, into hexadecimal. In the hexadecimal, the number 10 is nothing but represented as A, because hexadecimal is a alphanumeric. 0 to 9 as it is the decimal, from 10 onwards it is alphanumeric. 11 means B, 12 means C, 13 means D, 14 means E, 15 means F. Right? So here 15 is available. 15 is nothing but equivalent to decimal hexadecimal is F. Here 13 is available. 13 is hexadecimal equivalent is D. Right? So DF6. Right? So the decimal equivalent, the binary equivalent of this binary number, the equivalent hexadecimal number is DF6. Now we can combine this. DF6 base 16. Right? So in this what we are doing, the given binary number is grouped into 4 digits starting from LSB. If digits are shortage we can write 0, but here exactly 12 digits are available. So grouped into 4. Then write this weightage 8421. According to the digit add this number. Only these 2 are available. So 4 plus 2, 6. Then convert this into equivalent hexadecimal number. If alphanumeric is there, more than 10 is converted into alpha numeric. Then combine this value DF6. So the final value is DF6. Now we'll go to the second example. 1011110101. Right? So this is the given binary number. We need to convert into hexadecimal. What we got? 2E5. We got the answer 2E5 base 16. We will see how we got this value. How the answer is we got. So first we need to write this binary number into, group it into 4 digits starting from LSB. 4 digits. So it is what is available? 1010. Starting from LSB it is 1010. So 1010. Then 0111. another 4 digits. Only 0 1, but these 2 digits are shorted, add 0 0. So it will not affect, the original value will not be affected 0 0. So it is, so writing from 1 0 1 0 is first 4 digit, 0 1 1 1 second 4 digit, 0 1 is the third digit, but 2 shortage is there, so written 0 0. Right. So here only 10 digits are available. First 4 digit, second 4 digit, third 2 digits, another 2's are added. Now we need to convert these 4 digits separately into decimal separately. So what we do, we can write 8421, the weightage 8421 is written. What is 8421? 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. So that only we wrote. For simplification we wrote. Now how to convert this 0 1 0 1, second and fourth digits are there. So 8 is 0, equivalent is 0. Only 4 we have 1. So 4. 2 also 0. Only 1 we have, right? So 4 plus 1 5. This 1 into 4, 1 into 1. So 4 plus 1 5. This first and third digit is 0. So we can add, no need to add 8 plus 8 and 2. 8 and 2 become 0. Only 4 plus 1 5. Then similarly here, first 3 digits available, last one is 0. So this last one becomes 0. Only 8 plus 4 12, 12 plus 2 4, 8 plus 4 12, 12 plus 2 14. This is not here, this is 14, not 13, is 14, right? So this last digit is 0, so no need to add this one, 14. This one is 14. Similarly, yeah, only this one is available. The third, starting from LSB, only second digit. So 1 into 2, 2 only. This 8 is 0, 4 is 0, and this 1 also 0. Only 2 is available, right? Now we got 2, 14, 5. This 5 written as it is. 14, what is the 14 value is available here? 14 is nothing but E. Because in hexadecimal, 0 to 9 as it is decimal, from 10 onward it is alphanumeric. Alphabet, A, B, C, D. So 10 is A, 11 is B, like that. So 14 is nothing but E. These two as it is. So 2E5 is the hexadecimal equivalent of this given binary number, right? So how we are doing? The given binary number is grouped into 4 digits starting from LSB. The digits are sorted, add 0. Then write this weightage 8421. According to the digit, add the corresponding. 1 and 3 available mean 1 plus 4, 5. The second and fourth, 2 and 8 is 0, so it becomes 0. Here first 3 digits available. So 8 plus 4, 12, 12 plus 2, 14. Like that we need. Then we combine this. This is the equivalent hexadecimal number. So in this video we discussed 2 examples to convert binary to hexadecimal by grouping into 4 digits. Other conversion technique also available in separate videos. So subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.